All right. I'm a little late. Do this kind of quick. So Descartes' Rule of Science. So Rene Descartes, he came up with this. He came up with all sorts of stuff. He was kind of a smart guy. You can look him up. He was a mathematician, philosopher, all sorts of things, like a couple hundred years ago. But he came up with this rule that said you can determine how many positive and negative solutions any function is going to have of any degree with this one simple trick. So all we look at is how many times between coefficients, or not, but yeah, between coefficients, how many times does the sign change? So we put them in order. Even if you don't have one, like if we left out this 3x to the third, that's okay. You just put them in order, write down anything with a non-zero coefficient, and then we look how many times does the sign change. So we have a positive sign here. 3x to the third is positive as well. -9, that's negative. -23 is negative. -12, negative sign. Because really, this is all we care about, are just the signs today. The actual coefficients themselves doesn't matter so much. So positive, positive, negative, negative, negative. So this changed signs just once, right? So we say there is one potential positive solution. Okay? And then what if you want to know how many negative solutions are there? Well, that's why we practice doing f of negative x yesterday. So I'm going to rewrite my original function, only I'm going to replace all my x's with negative x. Negative x to the fourth plus 3 negative x to the third minus 9 negative x squared minus 23 times negative x minus 12. Okay? And then we simplify these. We're going to do that again. But really, all I care about are the signs, right? So negative x to the fourth power, since that's even, this is going to come out to be a positive. I really wanted that to be in red. Okay. Let's see. Negative x to the third is negative. So the second term is going to be negative. Negative x squared is positive, but a positive times a -9 is going to come out negative. See, negative 23 times negative x, this is going to be positive. And then minus 12, so it goes back to negative. All right, so I count up all my changes. So I have one change here, comes back to positive, back to negative. So that is 1, 2, 3 total changes. Okay, this is where it gets a little weird. So we say there are potentially 3 negative solutions. But without getting into too much detail, I'll tell you that answers come in pairs. So if there are 3 negative solutions, if we count down by 2, you can say there's also potentially just 1 negative solution. So anytime you're working out positive or negative, you count them up, okay? So like we had 3 here, so you start with that, and then you count down by 2s until you get to either 1 or 0. Okay, and we'll see some more examples, and that will hopefully make more sense. All right, so we have 1 positive solution, 3 or 1 negative solutions, but then we also have this third case of what about imaginary? Imaginary, I don't know how to spell it. So that's a whole extra step we got to take. So if I want to know how many imaginary solutions are, I need to go back to my original, and we see that it's x to the fourth. And one of the big rules of algebra is that if you have something to the fourth power, there are 4 answers out there somewhere, either positive, negative, or imaginary. So what we do is we make ourselves a happy little table here. So we say we have positive solutions, we have negative solutions, and we have imaginary. Okay, and then total. And I know the total is always going to be 4 here, because we have x to the fourth power. So we just need to list out all the different ways that we could take our positive and negative solutions and then make it add up to 4. So this is a little bit simple because I only have one positive solution. So it's either 1 positive and 3 negative, or 1 positive and 1 negative. Right? So all it is, I took all the combinations of positive and negative. So 1 and 3, or 1 and 1. Okay? Well, 1 and 3, that is already 4, so that accounts for all 4 solutions. So if there was 1 positive, 3 negative, there would be 0 imaginary solutions. Okay? If there's 1 positive and 1 negative, we still need a total of 4, so that means there are 2 imaginary solutions out. Okay? So that's the whole trick. If you want to find the imaginary solutions, we take all the combinations of positive and negative that we worked out, and then that's going to give us our, I wish my colors worked the way I wanted to like the first time. Okay. And that gives us all the possible imaginary solutions. So there's either 0 or 2. I should switch that order around because usually it goes greatest to least. So there you go. So there is 1 positive solution. There's either 3 or 1 negative solutions, or 2 or 0 imaginary solutions to our equation. X to the 4th plus 3x to the 3rd minus 9x squared minus 23x minus 12. I know that seems like a lot. Don't worry, we're going to practice this for a couple of days, and by the end, you will hopefully be an expert of how to work out stuff without having to graph it, in case you go back to a time where you can no longer graph equations. Okay, bye.